Good morning, everyone. Myself Dheeraj, and I'm from 4th Sem CSE. So here, my topic is the relational database. And what do you mean by relational data model? The relational data model introduced by E.F. Cod in 1970 and organizes the data into tables. Like also, it's called relational with the rows, tuples, and column attributes. The next slide is what is relation. A relation in database management system, a relation is known as structural collection of data organized into rows and columns, and each rows represent the entity of the record and column represent the attributes and the characteristics of the entity. Then next slide. And now the characteristics of relational model. And the characteristics are data organized into tables, unique table name, unique attributes name, and atomic values. The organizing the data into tables relation with the rows like tuples and the columns like attribute. It emphasizes the unique keys like atomic value and data impedance and engineering consistency and integrity through constraints like tables relation data like if the table relation data is structured into tables, which is also referred as the relation, and the rows, each row represents the record and instance of entity, and columns, each column represents the field or attribute of the entity. The key properties like unique keys, atomic keys, data independence, integrity constants, all are the key properties. So coming to the unique key, every table has a primary key like unique identity for each row, an atomic value like each attribute within the table contains a single individual value. It has only a single individual, not a multi-valued any attributes. And data impedance is nothing but changes the physical storage of the data, which do not affect the logical schema. Okay. Then coming to the integrity constants, it is the rules and enforced to the maintain of data accuracy and consistency. Then coming to the additional characteristics nothing but simple structure, flexibility, ACID properties, all are the additional characters. So data is stored in a straightforward tabular format. So it is been structured in simple, and even the database structure can be easily modified as needed. So it's flexibility and ACID properties nothing but relational database often employ ACID properties like atomicity, consistency, isolation, and durability to ensure the data integrity of the transaction. Then next slide. The next topic, the next topic is structure of a relation. Structure of a relation contains a relation that is table and tuple, that is row and attribute, that is column and domain, that is set of values. And in relation, the table organized with the rows like records or tuples and columns like attributes. So rows and columns like rows are nothing but the tuples, and each row represent with a single record or instant of an entity or a relationship. And even like that, only column is nothing but the attributes, and each column represents a specific characteristics or attribute of the entity relationship. And the relation schema, which consisting of the relation name and the attributes. So relation name is nothing but the name of the table, and attributes is nothing but column of the table, which includes the names of the data types, and a key which has the primary and the foreign keys. So the primary key which is used for the like it is a set of attributes that can be uniquely identifies each row. So uniquely it can identify the rows in a relation, and even the foreign key is nothing but it is one of the relation which refers to the primary key, so and of another relation, and establish the relation between the two. The properties of relation model: every row in a unique, like each tuple in a relation must have unique value for of its primary key, and the values for the atomic, like each cell in a table contains single individual value. Then next topic is, and the next slide is relational schema. So relational schema is nothing but which define the structure of relation, define the structure of the relation, and which specify the name of the relation and its attributes. Attributes nothing but column and their data types. Like example, student and student ID, name and age in the relation. Relational intelligence. A specific set of tuples in a relation at a given time, and it changes over the time as the data is updated. When the data is going to update it in the relational, so it changes over the time as data. Then the next slide is the domains. Domains is nothing but it is the set of available values of an attributes. So in the column, the set of values. where present in a column it is called as domains. And example like age domain, like integers between 0 and 150, it is the example for the domains. Next slide. The next slide is keys in relational model, and it contains the four keys, that is super key, candidate key, and primary key, and foreign key. So when coming to the super key, a set of one or more attributes that uniquely identifies the tuple in a relation. Example like student table, that which contains the roll number and name, roll number, name, and roll number, phone. This is the example for the super key. And the candidate key. Candidate key is nothing but the minimal super key. It is the minimal super key that has no subset, which does not have no subset. Like example, roll number or email in the student table. This is the example. Then coming to the primary key. Primary key is nothing but the candidate key selected to the uniquely identify tuples in a relation, so which cannot have the null values. Primary key does not have the null values, and the example is nothing but roll number as the primary key. And the foreign key is nothing but, so, and it is an attribute, you know, the attribute meaning of attribute is nothing but column. So in one relation it is refers to the primary key of another relations, so used to establish the enforce and a link to between the two tables. Example like department id, name, employee, or is a foreign key referencing the department ID in the department. Next slide. So this is the super key where I had explained you before behind this slide. So this is a set of one or more attributes uniquely identify the tuples, like example ID name. Then next is nothing but, and this is the candidate key, so which is a minimal super key and no extra attribute, and can be more than the one candidate. The next slide is primary key. So the next slide is primary key, and it is chosen candidate by the unique identifier tuples and must not have contains nulls and only one per relation. So next slide is foreign key. So this is the foreign key, an attribute in a one relation that refers to the primary key in another relation. So which is used for the referential integrity. The next slide is relational integrity constant, and it has the rules that which has the accuracy and consistency. And the first one is domain constant, and second is integrity, and the third one is referential integrity. Next, the first one is domain constant. So in domain constant, each attribute, like attribute is nothing but column. Each column must contain only one values from each domain. This is domain constant. Then coming to next, the next integrity is nothing but entity. So it's a primary key must not be null, and even each tuple is a uniquely identifiable in this entity integrity. And the last one is referential integrity. Foreign key values must referential integrity. I mean, it's a foreign key values must match primary key values in the referential relation or be null. The next slide is relational algebra review. So relational algebra review has the procedural require query languages. It has the query languages, and which is used for the operators to perform queries. Like the queries like operators is nothing but select, project, union, etc. These are all the operators which is used in the relational algebra overview. So the next slide is basic relational algebra operators. And the basic operators is nothing but the select, project, and union. Select is nothing but the filters rows, and project is nothing but selects the rows, and the union is nothing but combines the relation, one or another relation. It combines the relation. The next slide is more algebra operations. Okay, then the three operations are set difference, Cartesian product, and rename. Set difference is nothing but finds the tuples in one relation but not another relation. Difference is nothing but minus. The Cartesian product is nothing but which combines the tuples. I mean, it it is represented with a symbol into, and the rename is nothing but renames the relations. The next slide is join operations, and join operations combines the related tuples like theta join, equijoin, and natural join. The next slide. The next slide is normalization. Normalization is nothing but the process of organizing the data which reduces the redundancy and improve the integrity. Like uses the normal forms in 1NF, 2NF, 3NF, PCNF. These are the uses of normalization. And in normalization, the first one is first normal form, so which eliminates the repeating groups and ensures the atomicity of the values. This is done in the first one NF. And this slide contains the second normal form in normalization, which is based on the one NF and removes the partial dependency. So this is my topics and it's end over all this information. So thank you.